Okay, so just reminding you, we are solving problem, and I'm going to write this here. We are on chapter 6. We are solving problem 16 of Halliday's 9th edition. Okay, we already solved part A of this problem. Now we are going to solve part B. We are splitting it in 2 videos so it doesn't get too long. So part A, here we have the drawing. Here we have our object in this inclined. We put the weight, we put the force that we are applying so that this object wouldn't slide down, normal force and friction. So this part A was the object is at rest. Part B, and we are going to redraw these things here. So let me get some space. Okay. Let me erase the things. So part B of the problem is, there we are with our object. So let me put it here. Here is our object, okay? We have the weight. We already talked about it, so this has not changed. This is the weight of the object pointing down. We are applying, okay, so let me make this. This is our incline. We are applying this external force to try to hold this object. So we are applying this force, okay? And well, there is normal force perpendicular to the object. Now, part B of this problem is not preventing this object from sliding down. Part B of this problem, and I'm going to erase what we've done here. Part B of this problem is we are about to start moving this object up, okay? So we are about, not quite there, but we are at the brink of start moving this object up. If we are going to move this object up, friction is always against, not friction is always opposite. So there will be a friction force, but now careful. What is going to happen to this friction force? The friction force is going to be pointing opposite. So the friction force now is pointing down along this incline, opposite to the motion that we are trying to get now. We are trying to make this object moving up. We are at the brink, at the point where we are about to start changing from static friction to kinetic friction. In other words, we are at the point where this friction force, static friction force, becomes maximum. Okay, that's what the problem is asking us. That's our part B for this problem. Okay, so the question is, in this scenario where we have friction force, maximum, static, let's mark here static, what is the value of this force that we are applying, trying to bring this object up? Okay, all right, so that's what changed with respect to part B. And let's go for the equations. Sum of all the forces in the x direction equals to max. We are not moving yet, but we are at the point of starting. What do we have then along the x direction? So the frame is the same. X is there. So the force that we apply is along that frame that we chose, so it's plus F, and that's what we are trying to find. Friction force now is opposite, so it's minus. It's minus friction force. It is still static, and it's the maximum value of that static friction. Okay, remember, static friction can change, can go from 0 to its maximum value, and that's what we have there. Its maximum value. Okay, what else do we have in the x direction? As we already did in problem A, we have this component here of the mg, and this component here is opposite to 20 degrees. So we have here minus mg sine of 20 degrees. Okay, so that's what we have in the x direction, still no motion, 0. And the question is, what is the value of F? All right, so let's continue. F is minus friction force is that coefficient of static friction multiplied by Fn minus mg sine of 20 degrees equals to 0. Okay, what else do I need? Well, I have to find this, the normal force. So I go to find the normal force, I go to the sum of all the forces in the y direction. And what do I have in the y direction? Fn, pointing up along the y. And what else do I have? Minus mg. Now I have this component here of the mg, this component of this right triangle, this component along the y direction, which is adjacent to the angle. So that's why this is mg cosine of 20 degrees, 0. So Fn is mg cosine of 20 degrees. That's what we had already done also in part A of this problem. So I now put this Fn on this equation here, and we get that the force is the coefficient. Well, let's write the whole thing and then we simplify. So we have the force minus the coefficient of static friction. Now the value of Fn, well, mg cosine of 20 degrees minus mg sine of 20 degrees equal to 0. All that is numbers. At this point, you can already find the force. I'm just continuing to give you a nice force, not a nice equation for this force. But at this point here, you can already get the value, okay? But what is this final equation? Well, on the right side, I put everything to the right side, so everything becomes positive. I get mg, and then here we have sine of 20 degrees. Then I have plus the coefficient of static friction and cosine of 20 degrees. That is the final value of the force when we are about to start moving this object up, okay? And so we have to overcome now both. To be able to move it up, we have to overcome friction and overcome gravity along the gravity along the x-axis. So this is the end of part B. I'm going to stop the video and do part C in the following video so they don't get too long.